This is problem 3 on practice exam 3 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. You have a purely mathematical function, so what we're doing here you might see in calculus class. Y equals 3x squared minus 7x plus 4. We don't know what x is, we don't know what y is. There's no units, pure math problem. So let's take these one at a time. Part A is draw a good tangent line at x equals 3 and calculate the slope. So let's label the point. There it is. X equals 3. Draw a good tangent line. Now we have to estimate the rise and the run. That's 30. That's 35. So the rise is about 32. That's 2.1. It goes to 5. So the run is 2.9. Rise 32. The run's 2.9. The slope 32 divided by 2.9 is about 11. I probably shouldn't put that 0 there. Probably should call it 11. On to part B. Derive an expression for dy dx. We're going to take the derivative of both sides, and we're going to do it from scratch. And then we can calculate, we could use dy dx because that's the slope. If we plug in x equals 3, we can get the slope. So we're going to change x by dx, and we get a change in y, and we call that change dy. So we're going to plug in x plus dx everywhere we see an x in the normal equation, and then the y is going to change by dy. Should make sense. Now we're going to multiply out the right-hand side, and we get this. And you can see where y is. It's 3x squared, where you get in the normal equation. 3x squared minus 7x right here plus 4. That's y. 3x squared minus 7x plus 4. So we can get rid of this y over here, subtracting y from both sides. And of course, we're going to drop the dx squared term because that's nonlinear. We're using the infinitesimal. We're not using delta, so we can throw that away with impunity. So the result is this. That's the derivative. And what we're going to do to get the slope is to divide both sides by dx. So doing that gives 6x minus 7. That's the slope everywhere. We want the slope at x equals 3, so we plug in x equals 3. So we get 18 minus 7, which is 11. Oh my God. Yahoo. The derivative matches our estimate with the tangent line. Now we can go to part C. When x equals 3, we plug in x equals 3 to this equation, and we get 27 minus 21, which is 6 plus 4 is 10. And it looks like that's what it is, right? 3, and we go over, and we see it's 10. We're going to use the slope of the line, which is 11, at 3, to estimate the value of the function when x equals 2.999. And we know what it is at 3. It's 10. And we're going to check our answer by substituting in 2.999 in for x in the normal equation. So we know the value at x equals 3 is 10. We expect that the value at 2.999 is a little bit less than 10. Delta y, it's delta y less than 10. And we're going to use the slope to calculate delta y, because the slope is delta y over delta x. It's exactly dy dx. But if we're going to go away from the curve, and we're going to use a straight line, we should say it's about delta y over delta x, because the line's curved. So that's the slope, and the slope is about delta y over delta x. It's going to be really close because we're going such a small distance away. And delta x is minus 0.001, right? We were at 3 and we're going to 2.999. So delta x is minus 0.001, or we can solve this for delta y. And we get minus 0.011. It's that much less than 10. So we can subtract 0.011 from 10, and we get 9.989. That's our estimate from the slope. We can check to see if we're right. We just plug in 2.99 in for x. and we get 9.989003. A little bit off, and of course we should expect it to be a little bit off because line's not straight. We expected that. Okay, so part D. From the graph, you look really closely here, it looks like there's a minimum in here somewhere. Somewhere in here. We want to know where the minimum is. It's hard to tell from the graph. Maybe 1.2, I don't know. But we can use calculus to find the minimum because we know what the slope is, dy dx. We calculated it to be 6x minus 7 everywhere. We want to know where it's 0. So we plug in 0 for dy dx, and we're going to find x. So there's the slope, 0, 6x minus 7. That's a simple algebra. We can solve that for x. We add 7 to both sides and divide by 6. X is 7/6. 7/6, right in here. And we can use the normal function to figure out what y is there. If we plug in 7/6 into the normal equation, y is minus a 12th. So it's a little bit less under 0 at x equals 7/6. And that is some calculus.